Good day, everyone, or good night, depending where you are. So today I would like to share you something that I just developed, which is like it's a bit up a notch from the previous videos or LinkedIn posts, where I post about modeling using Python instead of our engine. Uh, I mean, from this post, I'm using mostly scikit-learn. It's basically this one-dimensional pixels classification as usual, nothing really advanced or whatever. But now I'm thinking about getting more advanced using, like convolution neural network and UNet. UNet. I think it's uh, some kind of architecture for modeling where you kind of have this kind of decode and encode. I could say, yeah, encode and decode the image. I mean, I'm not that really deep into machine learning stuff, but I can use it. So basically, we use this as a models where we classify land cover imagery. I mean, previously it's mostly a tabular data set. Like we make a pixel into a table, we train the table, then put the pixel again, then make an image. Set off the whole image as a patch, as a samples. Now we're gonna make it a little bit more different, a little bit more rich, I would say. Okay. Uh, so this is the models, the script that I made you. So basically, I'm trying to do line cover modeling, just like in previous videos, but now I'm using uh, UNet models, using Keras and Tensorflow, basically the advanced stuff, or where you guys call it deep learning, so which classical machine learning like random forest. No, this thing is more complex layers to make the models. So before we create models, we're gonna pre-process first because this data is not that easy to make because I think it's different than previous. Like you can just make a table, but here I'm thinking like using a patch or like some kind of grid of the image. So I'm using previous data sets, like land cover and Landsat imagery. So this is the same table that you see in previous videos. And this is the land cover of the region that we talked about. And map, and also this the cell imagery Landsat using infrared, so infrared 1 and infrared 2. Now what I want to make is that more advanced models on which per class, I'm gonna make some kind of buffer around it per class pixels, like some kind of buffer. Like here, I'm using 128 pixel size. So one patch is 128 pixel size, on which per line cover, I'm gonna make like 20 pictures or 20 patches, so that we're gonna have a quite even patches, so that you're not overfitting to one class or another's. Uh, So yeah, this is script I made. Maybe you can just read it. I will share a repository in the description videos or even LinkedIn. You can just check it out. So this is the output, basically, this kind of bunch of images. Uh, so this is like this little imagery of Landsat. So the first row is the I think the primary forest, yeah, primary forest. Second is secondary forest, etc., etc. I think there's only like some classes here, not all of us. So only 1, 2, 3, 4, 1, 2, 5, 6, 7, 8, 9, 11, etc. So not all the classes is showing up in this region, but it's fine. I mean, if you want to bigger array, we need to do the whole Indonesia. Maybe next time. I don't think. Maybe not. No, I don't think so. It's too big. So this is the imagery. You see the how to share it. I think I'm not sure which classes it is. So I also generated the patches for label. Here we go. Basically, the top is mostly primarily random forest. Well, most, you know, basically it's different classes. Just read just read the legend. Okay. Okay. Cool. Okay. After you generate all the images, all these patches, I save it in these folders. Okay. Maybe you guys want to follow. You need to read instruction in readme.md. Like here. But later, it will show in the repository. So yeah, save here in the images for the image and for the label here in LCS. Now let's come to the modeling part. Okay, this is the hard part and maybe take a lot of resources because you're gonna need a good computer for this. Okay, I just import it and I load the table as usual, for color mapping, legend, something. I load also the legend, the number of classes that possible in this our places. And I make a function basically to augment. So all the pages like 20 by, I would say, 20 images by 22 class, I would say. But it's not much. I want more. So basically what we did is that we're gonna augment it. We're gonna kind of flip it. We're gonna rotate the image, the patches, so that basically it will have more sample, but it will also very diverse, so that the model will actually learn instead of just remembering. So it's very simple augmentation. You rotate, you flip the image, basically you do everything with it. Okay. Now next, we're gonna load the image again. Basically the same thing like before. So the first row is parameter for us. I think the blackish row is the waters mostly. And I think this row is like transfiguration area. This row is build up. So yeah, it's just rows. Okay. Next is that we're gonna load also the labels. We're gonna augment. So every single one of these, we're gonna augment it. We're gonna augment all the images so that be more samples. And in the end, we get about like 1,000 patches or samples. Look at the first rows. The first in this tuples is the how many images or patches. This is the shape. So per image is have a height of 128 height and take width, and 3 is the channel. Channel here is the image for the Landsat imagery. I mean, we're using two channels, like using the infrared, sort of one and sort of two. I'm not using all the channel because maybe I just try to see how about three. And I don't think three is enough, I guess. I mean, you can see different with three bands, so we don't need that many. And for the label, of course, just one. There's only one images here. Although we're gonna change it into one hot classes, so the shape will be quite different. As in that the last indexes will be the number of the possible classes. This our case is 22. Okay, the trash too, same. Oh yeah, maybe I forgot. I split the test here. I'm using like, okay, what's the index I use? So using 8 to 2 ratio, so 8 for train and 2 for testing. So we get here number of training testing data. So we get 1,000 pages, 1,300 pages, and we get like 300 pages for tests. Then we get the models. I'm using this simple unit models. I think I get it from somewhere, but I modified quite a bit. I also make some parameter here that you can change if you want to do something with your model. For example, neuron. Neuron is like how many layers you can do it in the modeling. But also multiplication here. And the kernel is how big when the numpy array, when they see the neighborhood, a bigger kernel mean that it's gonna have a more generalized results, a more generals with fewer, although they have fewer information, they could detail sometime. Kernelity is basically also the same kernel, but it's for transpose. Yeah, transpose is when you increase, we call it not increase, more like you don't. It's the other way around for max pooling. Max pooling is like when you try to reproject your image into a low resolution, basically like that. But kernel transpose, I think I'm not really good at explaining this part, because this model I don't made the models. I kind of made the scripts and how it works, but like the whole the concept, I think it's not me. You can follow UNet, just read about UNet. There's a lot of resource in Google. I mean, what understand is big on this, but I have a use my own width, for the image instead of this kind of width and height. It's a bit different basically. So yeah, that's what I do. Change a bit something on something as long as it work. Why not? Uh, so basically, it's made of some convolution block. This block will be used for encode and decode. For encode, basically, we try to, let's say, cram it basically, cram into a more unreducible layers basically, but with more layers. With decode is when you turn the image back into an actual, lane cover that we can see. So yeah, this is how does it work. So this is the model we have. All right, maybe if you want to change, maybe to make a model simpler, you can decrease the kernel, or you can adjust the image size. So when you export the pre-processing, you can adjust the size. Instead of 128, you can make 64 or 32. Or you want to take up a notch, make it bigger, but it's gonna use more power to train it, and the model will be bigger. So it's your risk. I'm using 128. I think it's the good size, I would say. Okay. Okay. This is the model shape basically in the encode. So when encode, the shape is the output shape is getting smaller, although the neuron is getting bigger. Well, decode is the other way around, where the neuron is getting lower, but the shape is getting bigger, back to normals, to the truth 128. Okay, next is that we're gonna compile and train the model. This is one of the hardest part because it's gonna take me like 2 hours to train this model. I mean, if you know how to optimize, is sure, welcome. Because I'm using CPU only, not using GPU. I still don't know how to do it, but yeah, this is the result of the training, the historical. So basically, how it's progress. I mean, if we have a bit problem in seventh epoch, so yeah. So when the model stopped working, because I put a callback there, callback that if not growing after 5 try, just drop it, Okay, you can assess it, this result, which has a higher accuracy than previous model where we use only the second learn models, which are more complex, Keras Tensorflow models. As you can see that we have like 75% accuracy, like overalls, and I think for some classes is improving. So I think it's great. Not really over everything because this is test data. We don't even use it in the real data. Then this is the result. If you want to compare it side by side with the test data, so the left is the slide, the middle is the true labels, and the right is the prediction. As you can see, it's really close, between the compass, the satellite, between the true label and prediction labels. Really close. In fact, maybe you cannot see even this difference. In fact, sometimes I think the right one is better, because it's compasses the actual real area. But again, it's my own idea. I mean, say 75% accurate, but I'll take it. So yeah, I think we use like 300 of the images here. So that's 300. No, it's not 300. It's fewer because this is only not the one that we augment. So only the true one with the augmentation. Then we can save the models. I mean, you can use it again. You'd have to train the model again. You can save the models and use it in another time, or you can use it in your application or something. It's up to you guys. Okay. Next is that I would like to try to apply that to the whole image. So instead of just per patch, I think it's boring. We want the whole image, right? Although the input actually is only what 128 to 128. In the array shape, you can actually make it more. For example, I'm doing only 2560 by 2560. But the actually answer image is not that size, but we need to make it into 1-to-1 ratio because the input is 1-to-1 ratio. So we need to make it same size, although the actual answer image is not that size. So yeah. Okay, this is the image that we see from before. Then we try to predict it. Then this, so you do it by side. So the satellite the left, true label, and predict label. As you can, it's really close, like almost disconcerting at all of the result. Then I save it in accept the results. You can see so in QGIS, this is the results. Of prediction. Yeah. I mean the green one is the dark green is the main forest, the primary forest, while the I think red is the plantation. Yeah, this is a model. I mean the limit is quite accurate if you compare to this image. The slide image. There's some kind of border you can see there. And if you look at the city, the Sungai Penuh city or Kerinci, this is the lake. Yeah, it's really accurate mapped. The city too, it's really accurate, I would say. Basically, this is the one like dynamic word made, but it's our made. So I made it here. Haha. So it's not dynamic word, but I made it. It's cool. You guys do it. I mean, I don't actually made it. I mean, the label data is mostly from Ministry of Forestry, so thanks to them. Without them, I cannot make this. So it's not really me. So yeah. Still, I'm in just some models. It could be better or not. But yeah. Oh, this thing look weird. But again, I think this is not the, maybe I need to show the satellite imagery one. Maybe I can edit into XYZ, no, in the raster style. Can edit using protocols. Where's the other data there? Here we go. You can load the URL in QGIS, if you don't know. Tada. Is it edit? It's quite like, I'll change. Oh, they're gonna change the band here to B5, B6, and B7. Infrared, solar infrared 1, and solar infrared 2. Yep. Oof. Feels horrible. Maybe just the pyramid issue. It's fine. Okay, let's see the image here. If what we see in the label is true. Yep, I think composite. I mean, it's not really a forest, so they know it. Kind of. Yeah, I mean, it's not that good, but you can always improve it. I mean, I'm only use so few sample. We can use more sample here and a bigger area. So yeah, that's from me. I would say you can just open the repository for this. You can just, I'll share in the description how to use it. Then yeah, I forget to read it. It's the same method like before. Don't forget to install the script, everything. You know, maybe read more about unit. I need to learn more about unit. I mean, I understand how it work, but understand like how they made it. Was it good? Okay, now I guess that's it for me. I guess I'll see you around. I would say. Yeah, see ya. Enjoy.